Hi everyone, my name is Surendra and I work with Palo Alto Networks as a senior manager for enterprise security team. I'm here with my co-author and partner Venkata. We both come from the zero trust deployment experience in the infrastructure, and we thought of bringing that experience with the AI deployments and started doing some research work, keep us learning with all the things required from zero trust and mass integration perspective. We are also coming up with our book in sometime in August end, where we both are co-author. Uh, so today we are very excited to share our thoughts and learning journey. It's really very different for all of us. We are learning with this journey. So, Venkta, to you.
Yep. Thank you, Surendra. Hello, everyone. I'm Venkata from, I work as an application security engineer at Salesforce. And as Surendra mentioned, we've been authoring the book about how security comes into picture in the AI world. And we are very much excited about it. And without any further ado, we can dive into the topic. So, yeah. All right. So let's first start with the introduction of multi-agents. So a multi-agent system is a network of independent autonomous software agents. It's designed to perform a specific task or a function based on its assigned role. So agents can make decisions and take actions on their own using the data they observe or receive. So the agents don't just work in silos. They coordinate and collaborate using a central orchestrator or a communication framework. And the orchestrator manages the workflows, handles conflicts, and dynamically reallocates responsibilities among them. It's just like how an emergency response team would work. So why we need that? I mean, what are the key advantages? So the advantages are pretty obvious, right? Which are like its scalability and fault tolerant and real-time collaboration and modularity and task specialization. It's more like a delegation, delegating to whoever does their job in a best way. So yeah.
Okay, before we go and deep dive from the security perspective of multi-agent system, it's important that we take some time and talk about the reference architecture. As we can see in the architectural diagram itself, we have several components, and if we look at it, each layer has its own architecture playing a distinct role independently and but still collaboratively, with keeping security, observability, and flexibility in consideration. Now, the key component of the architecture and multi-agent system is orchestrator. I call it brain and soul of multi-agent system, considering its role. Like it coordinates task distribution, messaging workflows, info sequencing, and handles dependency. I can keep going around it. Now, who all are relying on this architecture? It's mostly agents. Agents, which are small software units working or designed to focus on a specific business logic or function, such as inventory management system, or from the technical perspective, running query or a specific time on a database based on customer request, scanning the internet from security perspective. A lot of them is there. Then comes the communication layer. Uh, if we talk about communication layer, each agent need to exchange message and share the context securely. This mostly being accomplished using APIs or PubSub models for flexibility. The important thing which we need to understand is the shared memory concept, where agents record the state, store the session context, and the log insight, and the whole autonomous system is depending on it. I would like to talk about policy plane in detail a little bit because that is where the zero trust deployment or the principle is being taking place, where you enforce identity, access control, or policy rule. Agent only do what they are permitted based on the policy plane, what sort of policies you have deployed, and that goes with the least privilege. Then comes the observability, allows for real-time monitoring, debugging, and auditing.
So yeah, now let's take a real world example of how a multi-agent system in a large scale CDN or edge environment would show up. I mean, how it would work. So in such platforms, you often have a specialized agents, like each handling a different specialized task. For example, like one manages TLS certificates, another handles DNS routing, and another takes care of bot mitigation or even content caching, and so on. So these agents operate independently, but still they need to coordinate seamlessly, especially during dynamic events like domain migration or policy changes. But with this power, there is a risk as well, right? So the risk always associated with this kind of power. So for instance, if the certificate manager fails or is compromised, so we are running it at the risk of like man in the middle attack. Or if the routing agent is misconfigured, then we could end up leaking customer metadata, or even the we create some outages. So even observability agents, if we don't secure them properly, they can be abused to inject or tamper logs. So to prevent this, we apply zero trust principles at agent level. That means like each agent only gets a scoped permission, and communication is mutually authenticated, and every action is logged and signed as a telemetric purpose. And malicious or malfunctioning agents can be quarantined dynamically. And this kind of agent level security posture helps us scale safely, even in a highly dynamic distributed edge systems.
Uh, let's take another use case. We are taking most of the security focus use case because we thought of giving the examples or the reference of the security leveraging mass and then talking about the zero trust. So here, the biggest challenge for almost every enterprise or organization is securing the attack surface in the cloud environment, irrespective of any cloud service provider. If you take a look, what are the critical components like API, storage bucket, or services which are accidentally get exposed to the internet? And why does this happen? It's usually because of the misconfigured infrastructure code or drift in the like ISE, or someone deploying unapproved change unintentionally or intentionally knowing the consequences of it. How do we solve it? We have certain type of agents. They are playing critical role in real time and making the assessment of the infrastructure. Like with the name we can easily figure out, like cloud asset agent. Then we have service map agent, drift watcher agent. So cloud agent, asset agent looks for anything in your cloud that is being publicly exposed. If there is a new delta, it will look whether it has gone through the proper process, PR, whether there is an API exposed, doesn't have any login or any other information being called out. Then you have a Kubernetes agent, which is monitoring your Kubernetes cluster time to time. Now, how does it work as a whole? Let's take a small example. We have a DevOps engineer. He accidentally deployed a billing API without any authentication. Now, your agent go and identified it within fraction of minutes and see that we don't have the right API controls or the TLS version or cipher to it. It take a look what was the PR, whether it got through a proper approval process. It shut down the whole thing, like blocking public access, fixing the code automatically with a pull request. It takes maximum 3 minutes, and then our system is again secure. This ensures that we are having a complete visibility into attack surface area, which traditional tools cannot do.
Yep. So now let's talk about why security in multi-agent system can get really tricky. Like each agent in a multi-agent system is typically autonomous, meaning it makes its own decisions, often based on partial knowledge. While that gives us agility and scalability, it also introduces the new class of risks. So, for example, like some agents may start with too much privilege, either due to misconfiguration or poorly scoped permissions. So that can also lead to privilege escalation or even unauthorized access to critical systems. So here we are talking about unauthorized access by agent, not even by external party. And another problem is like prompt injection, the classical problem in security, right? So especially in LLM powered agents, these agents are really easily gets manipulated if the inputs they receive are not filtered or validated. So that input could come from a user or another agent or even an external data. So we also see Risks like internal data leaks, where one agent inadvertently shares sensitive information with another agent, even if that agent is not authorized to see it. And collusion between agents is also another concern. In theory, multiple compromised agents could collaborate to bypass policies. And then there is the classic insider threat. An agent deployed with good intent starts behaving abnormally due to a bug or a logical flaw. So, while multi-agent system unlocks a lot of flexibility, it also expands the attack surface across like communication paths, memory, and the decision-making processes. And that's where the zero trust becomes really essential.
Okay. Uh, Now, this slide particularly reflect how zero trust principle can be mapped with the mass deployment in the infrastructure. Here, each agent is acts within the guardrails of zero trust from identity to access to communication. Now, mass and zero trust together create a framework where mass agent can work securely within their boundaries. The biggest thing which we are trying to address is unauthorized access and privilege escalation. It's very different from our legacy identity and access management. Now we are talking about non-human identities when they are trying to validate. And how this can be accomplished using just-in-time concept, least privileges, and this was being enforced using attribute-based and policy-based access control. The next one is like the biggest risk for our LLM model is prompt injection and data poisoning. And basically, our API gateways, the perimeter API gateways, are the front defense mechanism to protect us from the prompt injection attack. Because most of the prompt injection attack are coming from the untrust environment, where with the zero trust, we have a principle verify, trust, and then move, give the access. So that's how it works. The another issue is like data leakage between the agents. This is bigger problem when the whole system is automated and no human intervention. It's very difficult to deploy the microsegmentation. It's not like just you are doing it in the based on the different network. It's go with the granular access control and limit the lateral movement. Data is tagged and spoke like scope, limiting flow to authorized agent only. The biggest target for the zero trust, or sorry, for the mass system is like bad actors are always trying to perform the civil attacks and collision. When civil attacks like the rogue agents are sitting in the infrastructure and trying to impact the working criteria of the legit agent, and to remediate it, or I will say the guardrails around it, we need to have a cryptographical verifier their identity, which can be like MTLS, where the sender or receiver both have served to authenticate, and that also used for the enabling the encryption. Collision detection is basically by the behavior-based monitoring and traffic recognition. When we have a collision detection, it means the bad actor is already sitting in our infrastructure, and we are already in the verge of compromise.
So the next one is like unauthenticated, unauthorized access and privileges. So let's imagine an agent responsible for provisioning resources. It starts by deploying containers, but then, due to overly broad permissions, it ends up deleting firewall rules. And that's not a bug, that's a privilege escalation waiting to happen. In multi agent systems, it's common to over permission agents for convenience, but this becomes dangerous fast. So the answer is tight and just in time access, which is like where each agent gets exactly what it needs and only when it needs it. And even during long running sessions, we keep reevaluating the access policies dynamically, which by the policy enforcer. So an agent's environment changes, then so as the permissions that agent have. And that's how we break the set and forget model we traditionally use and replace it with adaptive trust.
Again, we come to the same prompt injection and the data poisoning, which is like the biggest problem. Why it is the biggest problem in the multi-agent system? We have multiple entry points where agents are fetching the data from the external sources, either using via URLs, API, or communicate with other LLM prompts. So they are very much exposed to this sort of attack. Now, the question comes how we can prevent it. We already discussed in a brief that our API gateways can be our first defense to protect against the prompt based attack. Here, the API gateways are like intercepting each input given by the either by the other agent or by the human by validating and filtering gateways for blocking malformed traffic. The another way can be context aware sanitization. The middleware agent can be playing a very vital role over here because it does not clean the data, but it also make decision who is the sender and what's the intent. And based on intent, it takes a decision. So it's like a smart agent doing the work on behalf of human. Then we have input schema, how users can uh, what sort of data structure or the defined structure it can take. All this sort of things plays a vital role when it comes to defend against the prompt injection. And the last one, which is very important, is quarantining and sandboxing the systems or the agents which we don't trust, and we put it into an isolated environment, and all their communication is being analyzed by either by AI model or by human verification.
Okay, the next one is like the data leak, right? So data doesn't just leak to outsiders, it can also leak between the agents too. Let's say an agent trained on billing data, it starts helping out a support agent. Now we have accidentally exposed financial records in a support workflow. So these kind of cross agent leaks happen when agents are not isolated clearly, either in memory or in scope or in communication. So we treat every agent like it's operating in a different trust zone. So we use like access tags, data sensitive labels, and also role based filters. So even when the agents collaborate, they can only pass along sanitized payloads. So think of it as like a clean room for inter-agent messaging.
The biggest problem with the multi agents or the target for the bad actors is civil attacks, collusion, and that all can happen if you are not using the secure communication. Multi-agent system can easily be targeted via advisory, creating multiple fake agents to mislead the system or flood in like false signals. To address these, we all should always use like cryptographically verify identity, which works on the concept of mutual TLS, where we encrypt the traffic and as well as both the sender and receiver will have the cert which will be used to authenticate and authorize. And this sort of cert should be, revoked from time to time. Even when the communication is happening, depend on the intent, it should happen. Next one is the collision attempt, where is the agents are that the attacker has taken over. They may act like a normal agent, but are secretly trying to exploit the system. Example: shared credentials, shared stolen credentials, or sending the hidden messages, modifying the policy enforcement logic, and even avoiding detection by coordinating their behavior. Every message is secured through end-to-end encryption if we want to provide the protection against this sort of collision attack. This layered defense ensures that even if the network is breached and the bad actor is sitting, attackers cannot impersonate agents or hijack the workflow and compromise the communication.
Okay, guys, I'm
So
gonna maybe this is a final slide. Maybe if you want to wrap up, we need to keep going. So if you
okay,
want to
yeah. So
take
yeah,
another minute or so, yeah.
yeah, we have the insider threat. How we actually will mitigate that, and the other one is like we have third party risks, and finally we'll be concluding. So do you want us to directly go to conclusion, Adam?
Yeah, please.
Okay, so yeah, to conclude, so to bring it all together, multi-agent systems are not a future concept. They are already here, and from customer support to orchestration to all the way to cloud defense, multi-agent systems are already in production today. But autonomy at scale introduces risk at scale too, and the old security models like trust once assume forever no longer would work. And that's why we need zero trust at the agent level: identity, isolation, context aware access, and strong observability. When done right, this approach lets you safely scale intelligence across your systems without letting chaos creep in. And that's what we are all in here for, right? So building a secure, intelligent, and self-defending systems for real world use. And yeah, that's all we have.
Thank you, everyone.
Beautiful. Thank you very much, guys. This is, again, Diego just began to allude to the risks involved here and how the way we think about security and trust needs to evolve. And I think you guys are essentially embodying what that evolution needs to look like. So I really appreciate the thoroughness and the thoughtfulness. It's very clear that you guys have spent a good amount of time thinking about how these things should operate. What's a good way to stay in touch with you and to follow your work and or connect with you?
LinkedIn. We are happy to post our LinkedIn profiles.
Awesome. Cool. If you want to drop it in the chat, we'll make sure.
Sure. In the private chat, please.
Yeah, that's fine. I'll drop it in the for the audience. Thank you very much, folks.
Thank you so much, guys. Thanks for the opportunity.